A circuit is set up as shown. The resistance of the variable resistor is set at 6 ohms and the lost volts due to the internal resistance of the battery is, and you're given your 5 choices. Now we must know what that circuit means. Everything inside that dotted box represents inside the cell itself. A cell consists of an EMF, in this case 12 volts, and an internal resistance of 4 ohms. Note, not an internal resistor, internal resistance, and that's the symbol for its internal resistance, a resistor. Now how do you do this? Well, the first thing we do is we've got to establish the current flowing in the circuit. Well, we know that's going to be 6 ohms there. We can find out the total resistance, because it's a series circuit, must be equal to 10 ohms. You're going to have the internal resistance 4 plus the external resistance 6 ohms. Total resistance is 10 ohms. The current flowing in that circuit will be then equal to the EMF, which is 12 volts, we call that V, divided by the total resistance. That's going to become 12 volts divided by 10 ohms. That's going to give you 1.2 amps. So we know there's going to be 1.2 amps flowing through the circuit. Now this is where we do our circuit Sudoku. What does that mean? We go to the resistance we're looking at, in this case this is the internal resistance, and we label all the things we know about it, V, I and R. We know its internal resistance is 4 ohms. We know the current flowing through it must be the same as it's all round the circuit, as 1.2 amps, and therefore we can find V by using V equals IR. And the current is going to be 1.2 times 4, and therefore we have got the potential difference of voltage across that resistor is going to be 4.8 volts, and that will be the lost volts. That will be the potential difference lost across that resistor. It'll be 4.8 volts. Now, in a twist to that question, they could ask you, what will be the terminal potential difference? Well, the terminal potential difference is what is available outside the terminals. And it's an easy story to understand. Think of a coulomb of charge going through this battery first of all. It's going to gain 12 joules per coulomb. It's going to be 12 volts gained. But when it gets to the internal resistance, it's going to lose the 4.8. So the terminal potential difference, on the other hand, would be equal to the EMF, 12 volts, take away the lost volts inside the internal resistance of the cell, which we worked out to be 4.8 volts. So in this case we'll get 12, take away 4 is going to give you 8, 8 take away the 0.8 is going to give you 7.2 volts. So there will only be 7.2 volts available at the terminal. But the question is only asking what will be the lost volts, and this method will find it, 4.8 volts.